The celestial body, Kepler-22b, sits 635 light-years away, spinning around a yellow star every 289 days. This giant ocean world is over 2 times larger than our home planet, hiding a global sea and a crushing surface gravity that instantly amplifies human weight 6-fold. A standard spacesuit here transforms into a brutal 1,700-pound trap, while the thick toxic atmosphere can completely collapse your human lungs in 1 single second. This expedition directly revealed the harsh physics of this cunning alien twin planet, showing why setting foot on its vast water-covered surface remains an absolute death sentence. The orbital mechanics of the alien world Kepler-22b reveal a tight cosmic loop. The planet maintains a permanent trajectory that is exactly 15% closer to its host star than the distance between our Earth and the Sunday. If this celestial body were moved directly into our solar system, its orbital path would sweep across the space bordering Earth and Venus. The native star driving this alien system, known as Kepler-22, is a yellow dwarf classified as a Type G star. This specific star possesses a measured surface temperature of about 5,500 Kelvin, which equals 5,200 degrees Celsius. However, our measurements prove that this star is 25% less luminous and 20% dimmer than our own Sunday. This natural coolness directly regulates the raw amount of heat the planet receives from its stellar companion. Consequently, this cosmic configuration maintains a theoretically ideal equilibrium temperature of 22 degrees Celsius on the planetary surface, provided the world possesses a temperate atmosphere structurally similar to our Earth. Beyond these orbital dynamics, planetary physicists at the U.S. Space Agency have established the first comprehensive physical simulation regarding this world, and the results outline a terrifying environment. This initial model determines that the celestial body is an enormous super-Earth exhibiting a physical radius that is 2.4 times larger than our planet. Furthermore, this massive twin accumulates a total planetary mass 36 times greater than our own world. According to the strict laws of acceleration, the gravitational pull generated at the surface in this particular model is exactly 6 times stronger than what we experience on Earth. This extreme downward pull alters all mechanical interactions and inflicts massive structural stress on any biological organism. For example, if you weigh exactly 175 pounds under our normal terrestrial conditions, you would experience an immediate, agonizing increase in weight of 1,050 pounds the very moment you stand here. Your muscular framework would struggle against your own heavily amplified mass. This inevitable physical law applies to your equipment as well. A standard astronaut suit weighing 290 pounds on our planet would instantly become a massive, crushing weight of 1,700 pounds, compressing your entire musculoskeletal system. How would you cope stepping out of the landing capsule and being instantly crushed by this immense gravity? Under this relentless mechanical law of nature, the sheer planetary pressure forces your fragile biological bone matrix to sustain unprecedented compression metrics. Every single blood vessel and joint in your body experiences immense gravitational drag, meaning your terrestrial skeletal frame must endure this severe structural load without any localized mechanical relief. Every single step you attempt demands extreme energy expenditure just to counter these baseline physical parameters, driving human physical endurance to its absolute limits. These empirical data are analyzed in depth in this space documentary. An alternative survey of the second physical model reveals a compressed air environment characterized by entirely distinct planetary dimensions. Compared to the previous mathematical calculations, these updated scientific measurements clearly indicate that the distant celestial body, Kepler-22b, possesses a physical radius 2.1 times larger than our own Earth. Furthermore, this unique structural configuration accumulates a total planetary mass 9.1 times greater than our home planet. This specific distribution of cosmic matter creates a milder surface gravitational pull, measuring exactly 2.07 times that of our own home planet. While this reduced downward force makes surface travel more feasible for human explorers who arrive here, navigating this rugged terrain still remains an extreme mechanical challenge that constantly tests the absolute limits of your transport technology. The temporal rhythm of this world is entirely dictated by its orbital movement around the central yellow parent star, where the complete orbital period lasts exactly 289.5 Earth days. Consequently, a single year on this alien entity is significantly shorter than our own terrestrial year, making the frequency of celebrating your birthdays much faster as time spins forward on this cosmic carousel. Under the direct influence of this unforgiving high-gravity environment, if you were to slip and fall into a 160-foot deep fissure, which is exactly equal to a 50-meter deep drop, the terrifyingly fast acceleration of unimpeded freefall would pull your biological body down at a speed exceeding 120 miles per hour, an absolute velocity equal to 492 kilometers per hour. This violent physical momentum ends by completely shattering your skeletal frame at the barren, rocky bottom of the ravine in less than a single second. This inescapable gravitational pull has completely reshaped the evolutionary design of the entire local alien vegetation across the planet. Living trees cannot grow tall into the thick alien atmosphere and were forced to evolve into short, stout structures to survive. They develop exceptionally thick, flattened trunks and deep, interwoven root networks, specifically engineered to withstand the constant physical downward pressure from above. The only organic organisms capable of reaching enormous sizes are native seaweed species, thanks to the continuous mechanical lift from the global ocean that actively buoys their heavy weight under the water. If you choose to settle permanently on this world, your biological body will undergo a rigorous adaptation process similar to terrestrial firefighters who constantly carry heavy loads during rescue operations. Your heart and muscles must work much harder to maintain basic blood circulation and human movement. Through multiple generations of natural evolution, the skeletons of human offspring born here will possess superior thickness and robust muscles designed specifically to withstand the constant downward pull on the planet core. This harsh nature and complex ecological dynamics have always been a central research topic in global cosmology. An analysis of the environmental architecture reveals that the atmospheric mechanics of Kepler-22b shift dramatically when evaluating the planetary climate under the severe tidal locking mechanism. If this massive celestial entity falls completely into the region of maximum gravitational pull exerted by its nearby host star, the entire planet becomes permanently locked onto its local rotation axis. This intense gravitational binding ensures that one half of the world is continuously exposed to perpetual light from the stellar companion, while the opposite half is plunged into an endless, frozen night. This severe solar division separates the global ocean surface into three distinct, mutually life-destroying environmental zones that challenge every facet of biological survival across this wet world. Within the sunlit hemisphere that is always facing the hot host star, a relentless thermodynamic process dominates the entire watery landscape. Liquid water evaporation occurs continuously with tremendous thermal intensity, lifting massive moisture volumes into the upper air currents. This enormous volume of accumulated water vapor rapidly pushes the localized atmospheric vapor pressure to its maximum possible level. This extreme moisture buildup triggers a powerful greenhouse effect, trapping heavy thermal radiation and covering the vast surface with exceptionally thick clouds of dense fog. This violent thermal convection process, driven by the constant temperature differential across the planet, continuously generates massive tropical storms, torrential downpours, and roaring hurricanes on a global scale, which aggressively disrupt the normal behavior of the surface water currents. How would your body react when walking between a temperature boundary torn into two opposing poles? In complete physical contrast to that turbulent, boiling hemisphere, the perpetual night surface of the planet is dominated by a freezing, icy night where no starlight ever penetrates the perpetual dark sky. If the planet lacked a thick, protective atmosphere to actively retain and circulate this precious thermal energy across the global hemispheres, the local surface temperature would rapidly plummet to -11 degrees Celsius. Furthermore, more extreme planetary climate models indicate that these unlit dark zones could easily reach a devastating -80 degrees Celsius. Without an atmospheric blanket to distribute heat evenly, all the concentrated thermal energy absorbed during the dayside would immediately escape directly into the absolute freezing void of outer space. This rapid energy loss turns the entire dark side into a desolate, icy wasteland characterized by frozen oceans and rigid thermal structures, closely resembling the harsh environment found on our own planet Mercury when it turns its back to the sun. The dense air currents here drop in temperature, creating a permanent downward flow of freezing gas that heavy gravity compresses against the solid frozen crust. The transition between these two lethal extremes creates a narrow, turbulent belt where cold, high-pressure air forcefully crashes into expanding warm vapor fronts, creating fierce, freezing windstorms that lash the landscape continuously. The environmental distribution on the surface of the massive planet Kepler-22b creates a narrow, habitable sliver of hope known as the Terminator Zone. Sandwiched between the two deadly, unforgiving zones of scorching permanent day and freezing permanent night, there lies a delicate, temperate boundary. Within this narrow geographic ring, intense, warm atmospheric currents migrating from the sunlit side forcefully collide with cold air currents moving from the dark hemisphere. This localized interaction establishes a stable and ideal thermal balance that allows water to maintain a consistent liquid state without boiling away or turning completely into blocks of solid ice. Consequently, this persistent moisture precipitates to form an interconnected system of flowing rivers and wide lakes across the rocky terrain, making this specific twilight ribbon the only area on the entire world capable of nurturing the most complex biological ecosystems. As life attempts to expand outward from this temperate boundary into the harsher regions of the planet, the biological mechanisms must shift completely to counter the total absence of starlight. In the vast expanses of water perpetually shrouded in absolute darkness, native microorganisms are forced to completely abandon the classic processes of photosynthesis. Instead, these primitive life forms switch entirely to advanced chemosynthesis to sustain their metabolic cycles. They successfully harness life-giving energy from highly concentrated chemical and mineral compounds, constantly erupting from active deep-sea thermal vents and underwater volcanic cracks. This localized survival strategy directly mirrors the resilient communities of extreme organisms that tightly cling to hydrothermal vents at the black bottom of our own terrestrial oceans, proving that absolute darkness is not a barrier to the genesis of basic organic life. Moving beyond microscopic organisms, the structural design of hypothetical complex animals you might encounter on this world follows rigid physiological rules. To efficiently hunt for vital nutrients and communicate with each other in the endless night, larger organisms develop an unusual, highly specialized bioluminescent mechanism that illuminates the dark waters and cold land corridors. On the rare patches of solid ground above the global sea, land animals must adapt to the severe gravitational stress of the planet. These native organisms would be exceptionally short, incredibly muscular, and move efficiently on multiple limbs like polypedal reptiles. This multi-legged architecture is a mechanical necessity to maximize the dispersion of extreme gravitational pressure across a wider surface area. Furthermore, their heavy bodies would be entirely covered by a hard, horn-like protective shell composed of very dense chitin or reinforced calcite. This external armor acts as a rigid skeletal framework, specifically designed to prevent their delicate internal organs from being completely crushed under the planet's relentless physical stress. Finally, the thick alien sky would be completely devoid of any flying creatures, as the overwhelming downward gravitational acceleration makes aerodynamic lift and takeoff entirely impossible for any biological wing structure. Decoding these hypothetical evolutionary parameters depends entirely on in-depth research in the field of astrophysics. The physical examination of the gaseous layer surrounding Kepler-22b reveals an alternative planetary nightmare if the world experiences a normal rotation pattern instead of a permanent stellar lock. Given its massive physical dimensions, planetary formation models indicate that a normally rotating world would naturally retain a dense, primordial atmosphere dominated almost entirely by hydrogen and helium gases, closely resembling the complex, deep chemical compositions observed within the massive gas giants of our own solar system. This extraordinarily thick envelope of light elements generates an overwhelming downward physical force across the entire world. This immense, crushing air pressure pressing down continuously on the surface radically compresses the global water flow, completely transforming the vast global ocean into an unstable supercritical state. In this exotic, high-pressure state of matter, the fluid exists right on the blurry boundary between a true liquid and a heavy gas, entirely eliminating the structural integrity required to form normal biological cell membrane structures for living organisms. Furthermore, you would find this heavy air completely devoid of any molecular oxygen to sustain basic human respiration, turning the entire sky into a suffocating, unbreathable ceiling. Under these specific structural conditions, the sheer physical weight of the surrounding gases poses an immediate, lethal hazard to human explorers who arrive here. If an astronaut carelessly or accidentally removes their protective helmet while standing on this alien surface, the extreme pressure difference between the fragile, normal interior environment of their biological body and the crushing external environment outside would instantly trigger a devastating barotrauma. The sudden, violent mechanical stress generated by this massive atmospheric differential would completely suffocate, collapse, and physically shatter both human lungs in just one single second of exposure. This immediate respiratory destruction triggers a catastrophic chain reaction of systemic internal trauma, causing a fatal sequence of multiple organ failure across the entire biological body and leading to immediate biological death without any possibility of human survival or medical intervention. Alternatively, different climate simulations explore a scenario where excessive carbon dioxide accumulates heavily within the world's gaseous envelope, turning this distant planet into a terrifying second Venus. Under this specific model, a suffocating layer of air exactly 90 times thicker than our own planet Earth's protective atmosphere completely traps all incoming stellar heat radiation from its parent star. This relentless thermal trapping rapidly heats the planetary surface to a scorching 460 degrees Celsius, a temperature far exceeding the melting point of lead. This extreme thermal energy completely evaporates all liquid water on the surface and violently incinerates even the most primitive organic molecules, neutralizing any potential genesis of life completely. Any remaining liquid seawater under this intense chemical regime would rapidly transform into a highly acidic solution, heavily contaminated with toxic accumulated dissolved heavy metals leached directly from the planet's rocky crust. All of this atmospheric simulation data is being expanded for analysis beyond the space region. The physical mapping of the outermost layer of Kepler-22b shifts our perspective to an unforgiving marine landscape. Comprehensive planetary data indicate that this enormous celestial twin is completely covered by a global ocean with an average depth of up to 160 feet, which is approximately 50 meters. Because this planet exhibits a physical radius 2.4 times larger than our Earth, its total surface area is mathematically enormous. As a direct structural consequence, stable dry land is extremely scarce across the planet, turning any strategic search for a solid landmass or an isolated rocky island to achieve a safe landing into an impossible challenge for human engineering. Furthermore, the baseline chemical composition of this global sea remains a profound variable, meaning that any liquid water you discover could be heavily saturated with toxic element distributions or highly corrosive localized acids leached from the submerged planetary crust, defying standard biological survival parameters. Beyond these hostile surface characteristics, humanity's greatest scientific obstacle to physical exploration remains the sheer astronomical wall of distance separating our civilizations. Kepler-22b is located exactly 635 light-years away from our own home solar system. To put this vast void into a clear technological context, we can evaluate the mechanical performance of our fastest man-made spacecraft currently traveling through the dark void, which is the Parker Solar Probe, developed by the famous United States Space Agency. During its closest approaches, this automated probe achieves a record speed of 430,000 miles per hour, a velocity equivalent to 119 kilometers per second. While this mechanical milestone represents a striking engineering achievement for our species, this velocity only reaches a mere 0.064% of the fundamental speed of light. This profound mechanical limitation means that it would take this specific spacecraft exactly 99,000 years of continuous, unimpeded flight through interstellar space to reach the outermost atmospheric boundaries of Kepler-22b. This paralyzing timeline remains unyielding even when calculating the theoretical limits of highly advanced future propulsion technology. Even if our descendants successfully develop advanced interstellar nuclear fission or advanced nuclear fusion engines capable of propelling a massive crewed spacecraft to 10% of the speed of light, the journey would still require 6,350 years of continuous travel. Similarly, a highly advanced space-bending spacecraft capable of reaching an unprecedented 20% of the speed of light would still need exactly 3,175 Earth years to arrive at the destination. This crushing silence extends to our electromagnetic communication systems. If we were to transmit a high-powered radio signal from Earth today, that focused beam of energy would still take exactly 635 years just to reach the thick atmosphere of that distant ocean world. This confirms a 95% chance of advancing the universe-explained and space exploration journey. The Kepler-22b file proves our universe has no paradise. This world, full of physical pitfalls, bone-shattering gravity, and lung-destroying pressure, is a chilling warning from space. A vast ocean teeming with dangers acts as a great mirror reflecting the unique value and perfect protective shield of our Earth's atmosphere. Understanding these devastating biological limitations through the science documentary filter doesn't deter us, but elevates our knowledge in the modern realm of Science Explained. The science journey helps us appreciate our one and only green home in the vast expanse of the universe. Thank you so very much for watching this deep cosmic journey. Exploring these distant worlds helps us appreciate the rare beauty of our own home planet. If you love discovering the hidden secrets of the dark cosmos, please subscribe and leave a comment below. We will keep exploring. Goodbye, everyone.